Okay, now we're doing experiment 10 on the properties of lipids. Remember that a lipid is a biomolecule that is insoluble in water and soluble in organic solvents. We're going to start out with about 8 of these guys here in the order of lauric acid, the one on your right, followed by oleic acid, it's in this one. Then we have olive oil, coconut oil, sapphire oil, lecithin, cholesterol, and vitamin A, which is a fat-soluble vitamin. We've already added, we kind of doubled our recipe from 5 drops to 10. So I'm going to double the amount of water we put in there, and I'm going to use a pipette instead of counting drops. That's about 2.5 milliliters of water for each one of these. So you give them a little mix and see what happens. Okay, taking a look, not much solubility going on in any of these because they're all lipids. If you look at this one, when I shake it up, you see that it's kind of cloudy right there. Stuff comes back on the top, so that's how you know it's not soluble. Same thing with the olive oil. You can see the layers separating. Coconut oil, which is a solid room temperature, if you remember that from 1405. This is safflower oil. Again, separates out. Same thing with lecithin. Cholesterol. Finally, the vitamin A. We do the same thing with methylene chloride, which is an organic solvent, and see how they compare. Okay, now we're going to continue by using the organic solvent with the same list of lipids, starting out again with the lauric acid, followed by the oleic acid, olive oil, coconut oil, safflower oil, lecithin, cholesterol, and vitamin A. Again, we double everything, so now I'm going to put in 40 milliliters, 2.5 milliliters of the methylene chloride, which is twice the normal recipe. It's also referred to as dichloromethane, both the same name for the same product. Let's take a look at these and compare them to the other ones we just did, with just plain old water. This is the coconut oil with water. This is the coconut oil with dichloromethane. Notice the difference. With the dichloromethane on this side, it's soluble. With the water, it's insoluble, just like you're supposed to see with lipids. The olive oil. Notice when I shake it up, it's nice and cloudy. You got 2 layers on it. Olive oil now with dichloromethane, only 1 layer. See it? Nice and clear. Now we have the oleic acid, sorry. Again, that's 2 layers again. The oleic acid over here is only 1 layer, it's nice and soluble. You can see those. Lauric acid, similar thing happening with it. Dichloromethane on this side, water on this side. Notice that the lauric acid has dissolved in the dichloromethane. Go forth on down the line. I don't take out each one of them at a time. Here's my safflower oil with dichloromethane with water. See the difference? Our lecithin shows some solubility with dichloromethane, but it's still not a lot because we might have put a little bit too much in here. But this is with the water on this side. This is with the dichloromethane. I would say there's probably more soluble in this one than in that one. Still not quite soluble. Cholesterol, really more soluble in dichloromethane than in the water. You know, it's going to have the large chunks going up and down the sides like we have over here. And our last one is the vitamin A with water, with the dichloromethane. There is some solubility in the dichloromethane. Again, if we have something different, like too much of one in the one test tube versus the other. So this is all nice and cloudy, but this is clearer. There's some drops in there, but it's definitely more soluble with the dichloromethane. Okay, now we're on to part C, the neutralization test on the lipid experiment. We're using 5 molar sodium hydroxide solution. It's a nice clear solution inside the bottle. This is what our test tubes look like now. This is my first one is the lauric acid from part A. Big old chunk floating in there, and this is the oleic acid from part A. It's floating on top is a yellow waxy material. We'll add the sodium hydroxide until we get the solution to be basic. First time we start off with was 20 drops of sodium, 5 moles sodium hydroxide. So let me go with that first, and then we'll mix it up, and then we'll see what happens. Checking to see if it's basic now. Take a little drop out of there and put it on a piece of pH paper. You can see the pH paper turn nice and blue right there. One more time. Turns nice and blue. That was that one. Rest of it back in there. Take a little bit of this solution out of the oleic acid material. Check it out. Again. Now that we know it's basic, you can see that, turning blue. Then we'll take a look and you can describe what this looks like. Remember what we had from the beginning. Now that we mix this up with the sodium hydroxide, we have a much larger volume of solids in there. Floating on the top. Same thing over here with the oleic acid. This is the lauric acid, and this one is the oleic acid. And I want you to think about what happened when we put the sodium hydroxide in there. What did we make? Based off of what we had in our lectures. what do you think would probably be happening when you put the sodium hydroxide in? Our last test that we're doing for the lipids is the unsaturation test. We have lauric acid, followed by oleic acid, followed by olive oil. And then our last thing in here is going to be coconut oil. We put it in drop wise and see how many drops it takes to turn this stuff. Red. So how long it takes to get to the red color. This is what the bromine in solution looks like. It is a reddish color. Starting out with the lauric acid. It's already red, probably less than 10 that I put in there. This thing is not cooperating with me. It's dripping like really crazy right now. Just that so it doesn't come out again. Next one's oleic acid. Do that one. Already got about 30 in there now. It's gonna be a lot. I don't think we're gonna get to that color change on this material. About 40. $50. $55. $60. This takes a while when you have a lot of polyunsaturated in that fat. 65. $70. We're just going to call it greater than 70 here. That's 90. Starting to change color now at about 90. That's 93. Just say greater than 93. Move on to the next one. Okay, olive oil is coming up next. This is the olive oil, what it looks like. I gotta get my hand over the other side there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Shake it up. Nothing's changing. There's 20. Still. 30. 40. 50. 60. 70. 80. And 90. It's going to take a lot. 95. 100. Lower that's greater than 100. Take a look. A whole lot more to do that with. Okay, the last one's coconut oil. It should take less. You see? 1, 2, 3, 4, 5, 6, 7, 8. About 8 is already changed. So it didn't take very much for either the lauric acid or the coconut oil. It took quite a bit for lead and olive oil because they're polyunsaturated. This one's about 10 drops, and this is only about 8, I think. These are well up close to 100.